A couple months ago, I was browsing the internet looking for different things to build, and I came across this Minecraft block 3D model on Thingiverse. And in the pictures, it had it all lit up and it looked really cool to build. So I decided to take it, print it, and see if I could make it into a lamp. And it was going to be perfect for my 3D printer because at the time I had just a printer that was 4 inches by 4 inches. So I could make the model about 3.8 and it would be perfect. So I printed that out and I was thinking, what electronics do I have just laying around? So I found a little Arduino Nano, I found a little battery pack and a little strip of LED that I was thinking it was going to be perfect. I was going to fit it all in there and it would light up perfectly. So I got all the electronics working before the print was done because the print took about 16 hours. And as soon as I got the print done and tried to fit all the electronics inside, I realized that 3.8 inches is not very big and it did not fit at all. So I was going to have to rethink my entire solution. Now fast forward 2 months to now, I decided to start working on it again. I just browsed the internet looking at different ways people had it, and on every single one they had a power cord running out or some kind of wires running out. I was going to rethink all of my electronics and have it all encased inside the cube. So this is going to require some modification to the 3D model for a small housing for the electronics where the LEDs would sit. So I decided to go with the smallest microcontroller I could find possible, which was the Adafruit Trinket, which I believe is just an AT-Tiny 85 on a PCB. And it was going to work perfect for the LEDs I was going to choose, which is the NeoPixel programmable RGB LEDs, which are perfect because all you have to do is send it like 2 lines of code and you can have it be whatever color you want. So I decided to add an ESP8266, which is a Wi-Fi module, so I could control the lights through a web client because it would be all enclosed and I wouldn't be able to switch to LEDs. Alright, before I show you the final product, I thought I'd show you the code that I used. So this right here is the code that I used for the WESP8266 for the Wi-Fi client. Right here is where you would put your SSID and then your password for your Wi-Fi. And then I defined GPIO 0, 2, and 3. And this would be what I basically enable that I send to the Arduino Trinket. Here, just defining the digital rights and the pin modes. Here's where you set up your, you begin your Wi-Fi. So I'm not 100% sure how this works. I just kind of copied and pasted and made it work for my situation. And I'm not going to go through all of it because this would be like a 30-minute video, but basically here's where you set up your buttons and you define your labels. And here's where you define your HTML for your page that's going to be on your local IP address. And then if we jump over to this will be our Trinket code that will run all the LED colors and the output too. So basically I just used the Adafruit NeoPixel library, which is very simple to use. All you have to do is define your LED pin, and then here's the one command you do to define your strip and your LED count. And then down here is here's the main loop. Basically I just read the digital inputs from the ESP8266 and then I go into this function, and from here I just to see if it's low or if it's high, and depending on the 8 different values of the 3 variables I determine what color it is. And then so basically I just have the different colors: teal, blue, green, yellow, red, off, and pink, and rainbow. I decided to go with off on the 101 because I originally had off on the 000, but I wanted, if it wasn't connected to my Wi-Fi, I wanted it to at least be, you know, the Minecraft diamond color. Alright, I forgot to show you one last thing. So this is the web page that the ESP8266 makes, and you can see here's our labels and all our buttons that we defined, and when you click through all of these different combinations of on or off, that's what changes the code in the Arduino Trinket to change the colors of the lights. So it's been a few weeks, and there's some technical difficulties that I was working through, but it's all finished now and it's ready to go. So I'll throw the schematic somewhere up on the screen. I would show you my schematic from my PCB layout, but unfortunately I got something wrong. I forgot one of the grounds, and I'll just show you this Illustrator image that I originally drew. Here is my original PCB that I ended up just using a regular perf board, and after I had soldered everything up, I realized I messed up the Arduino program, and when I tried to reprogram it, it would not program at all. So I decided to just do a printed circuit board. So here's the printed circuit board. I decided to use headers on the board so it'd be easy to debug if I was having issues with the Arduino or the ESP8266, which I did not. So the only thing I did mess up on is I forgot to ground the LEDs to everything else, so I just did a little black wire. I ended up using 3 screw terminals to connect the LEDs. So I have the LEDs kind of in position. This is the mount, this is the part that goes inside where the printed circuit board will go. So here is the final finished cube. To diffuse the light, I ended up going with 3D printed inserts that I used my clear filament, and it actually turned out really nice. I made a spot for a switch to turn on or off the battery, and here's the module that plugs into the printed circuit board. So now that's all wired up, now it's just time to fit it all together. I did end up making holes for threaded inserts so I can have a good screw connection. And now let's try to fit it all together. Alright, there we go. Got everything screwed together. Now the only thing is to turn it on. I think it takes a second to connect to the Wi-Fi. Okay, probably should have tested it before I screwed it all together. Oh, never mind. It works. So I know this project took a little longer than I wanted to, but had some issues with the electronics, the 3D printing, and just putting it all together. But finally finished, it looks amazing, and I hope you guys go out there and build one yourself. So like always, leave a like, comment, subscribe. I got some more good ideas coming in the future. Until next time, go out there, learn, build, and have fun.